In this video, we'll learn about how to calculate the incremental cost of borrowing additional money. So let's look at a simple example. We have this fixed rate mortgage for 25 years. So we have two options. You can borrow $80,000 and the interest rate is 12%. However, if you want to increase the borrowed amount to $90,000, the interest rate is 13%. So now the question is, what is the incremental cost of obtaining the additional $10,000? So although on paper, the interest rate only increased by 1%, but we know that you would have to pay for the additional 1% for the entire $90,000. So the effective rate for the additional $10,000 should be higher than 1%. So what's the procedure? First, you calculate the payments for both loans. We're talking about $80,000 loan at a lower interest rate and a $90,000 loan for a higher interest rate. And then you will calculate the difference in balance and payments. Next, you would have a difference in monthly payments. You have a difference in the initial loan balance. You calculate the IRR to get the interest rate of the differences. Let's look into the details. So we should know how to calculate the loan balance very easily, right? It's $90,000 minus $80,000, you get $10,000 cash immediately. With the monthly payments, you can, I'm pretty sure you know how to do the calculation. For the $80,000 loan, the monthly payment is $842.58. And when you borrow $90,000 for 13%, it's $1,015.05. Why is that? Because both the loan amount and also the interest rate increase. So now we calculate the difference in monthly payment is $172.47. So if you borrow the $90,000, you would pay $172 more every month. So what do you get for paying the additional? Well, your initial cash is $10,000 more for choosing the $90,000. So now we would calculate the IRR for borrowing the additional $10,000. We know the PV is $10,000. We know the payment is $172.47. So you see that the payment is negative, the PV is positive. So you can keep it that way, or you can set the payment to be positive, the PV to be negative, as long as the signs are different. Because one is the additional dollar gain to you, one is the additional payments. So the signs are opposite. So we know that because the loans are 25 years, we would have to make 300 payments. Because both options, the loans will fully amortize, the future value after 25 years is 0. We have the monthly payment, we have N, we have future value, we have the present value. We solve for the discount rate. It's 1.71%, and you multiply it by 12, you get a 20.57%. So now we see that although on paper, the interest rate only increased by 1%, but the effective cost or the incremental cost of borrowing the additional fund is 20.57%. So the question is this a good deal? Well, how do you assess whether this is a good deal? Well, instead of getting a $90,000 loan, you can get a second mortgage for $10,000 at a discount rate that's market. And also you borrow the $80,000 loan at the lower interest rate. So now we look for the interest rate, the market rate for the second loan for this amount. So if in the market, all the valuable second loans are higher than this percent, higher than this cost every year, then the 20.57% is a good deal. Then you should go with the $90,000 loan. However, if you can find a second mortgage for maybe 15% or even 19%, then you should go with $80,000 loan at the lower interest rate plus the $10,000 loan at the market rate. That concludes our calculation.